Alright, today we're going to look at how to apply a function to any number of arguments. Like most of the time what we've been doing here is we've been doing lambda, and then we do like a list of the arguments that we want, a and b, and then you do something with a and b, like add them together. Well, that's just a procedure, but what if you want to, you don't know how many of these things you want. Let's say like in Scheme the plus procedure is like this, so you can add 1 and 2 together, but you can also add 1, 2 and 9. You can just keep adding things and it will just add them up. Same with the and, or procedures, max and min, plus, minus, multiply, divide. Alright, so how do you define that yourself? There's multiple ways of doing it. So the first way, let's define, let's just pretend we've got a function called add2, which just adds a and b together, plus a and b. Alright, that's sort of dumb, but that's all we've got. Alright, now let's define our own function named add that will add multiple numbers together. So the first way that we can do it is define add lambda, and instead of putting a list of arguments like this, see that's a list in parentheses, you just put some name like args, or you could put arguments, or you could put hi. You know, it doesn't matter, you just have to name it something. So lambda args, typically you always name it args because that stands for arguments. Okay, now this is a list, and let me show you. So if we just return args, then we run add 1, 2, 3, 4, we get a list that is the list of everything we put in here. Alright, so the first thing that we can do with this is we could define a helping procedure that would handle the arguments. So like we could do let rec helper, let me put this down there, let rec helper lambda ls. Alright, so the helper is going to take the list of arguments and it's going to go recursively through them, adding them together, sort of like the fold function would do. Alright, so if null ls, then we return 0, otherwise we do add 2 to the the car of ls onto the helper of the CUDA of ls. Alright, then we run helper on args. Alright, now let's see if that will actually work. So add, just try 1 and 2 for now. Alright, add 1, 2, 3. Alright, well that works. Okay, so that's one way to do it, but of course the disadvantage of this is it has to bind this local helping procedure, which takes some time and some extra memory. So another way to do it is the apply function, by using the apply function. So apply will take a list of arguments, so let's say we got the list like 1, 2, 3, and we want those to be these arguments here, but how can we do that? Well, I just pretty much told you use apply. So I think apply, you use I think you put the function first, so let's apply add to 1, 2, 3, see if that works. Yes, alright. So that basically, that statement means this, add 1, 2, 3. Okay, so let's rewrite add here using apply without defining a new helper procedure. So add lambda args. Okay, so we've got a list of arguments here. But alright, so yes, we got the list of arguments, and let's see, so if there's nothing in the list, then it's just add by itself. What do we want to do? Let's see what scheme does. Right, it just adds 0, so let's do this. If null args, then we'll just return 0, otherwise we'll add the car of ls, or the car of args, onto, and here's where we use apply. What do we want to apply next? You can guess we can't apply args to add, otherwise it would be an infinite loop, it would just keep going. So we have to apply the CUDA of args, apply add to the CUDA of args. Alright, so apply add onto the CUDA of args. Alright, let's try this then. Add 1, 2, 3. Oh, I don't know if there's something wrong then with my program, since it's obviously got some sort of infinite loop going here. Better stop it. I think that Dr. Scheme is having a bit of a problem right now. I don't know why. I can't seem to stop it. Alright, let's hold on a second here. Oh, I think that my system's running some sort of disk check right now. That's pretty inconvenient. Let me try and do this in Petit Chess Scheme and see if it does it right. Petit. Alright. If I could copy and paste that. Oh. Alright, there we go. Let's kill it. Alright, so was that an infinite loop or was it not? Excuse me while I cover that back up. Alright, so we added the car of args onto oh yes, that is an infinite loop, because we're calling add. Alright, so let's look at this, what this will do. This is a fairly good exercise here. So add 1, 2, 3 will call add 1 onto the add of 2 and 3. Alright, which will call add 1 onto the add, oh no, onto the what is add 2 and 3? That will be add 2 onto the add 3. Okay. So what does add 3 equal? Well, that will eventually equal 0, but so it would be add 1 onto the add 2 of the so it would be 3 plus the CUDA, which is 0, so it would be add 3, 0. Alright, then what's add 3, 0? Let's just do add 3, 0 by itself. Is let's see, add 3, 0 is add 3 onto the add of 0. Alright, and of course then add 0 will turn back into add 0 plus 0, and it will just keep going and going and going. Alright, so the thing we have to do is we can't call add itself, we have to call this other one here add 2. That just does the simple two argument addition. Alright, so now let's do add 1, 2, 3, and there we go, it works just fine. Now unfortunately, since we took that great detour there, I don't have time to show you the last bit, but in the next video it should be quite short, and I'll show you how to do the last way to do this.